Welcome to Intro to TypeScript. Let's talk about it a little bit. So, the quick hits. TypeScript is a typed superset of JS. So, without getting too mathy about it, this is a set, this is a superset. So everything inside of the set is also inside of the superset. That means all JavaScript is valid TypeScript. There's a lot of things in programming that work this way with sets and supersets and stuff. So all of our JavaScript is also valid TS. TS adds a few other things. The most important of which is type safety. Type safety means that somewhere in your code, if you try to use a number somewhere where you're expecting a string, it won't even run your code. That's huge because it allows us to catch problems at compile time instead of, what's the alternative?
Runtime.
When the users find it.
Runtime. We catch the problems as we're writing them, not when we're running the code. That's better. Compile time, that's a faster feedback loop. That is, that's the computer catching our problems before a user does. It's cheaper because we spend less time making a mistake. That's part of the tighter feedback loop. Less time to catch the mistake, so less time to fix it. We just made it. We don't need to reestablish context when we're debugging it later. So type safety helps us catch problems faster. TS in particular does a kind of typing called structural typing that allows it to infer most types. When we do Java a little bit later, Java is not structurally typed. It's nominally typed, which is the other way to do that. Java does not infer much of anything. If you do nominal typing, very difficult to infer something. You do structural typing, you can infer most things. I wouldn't worry too much about like really grokking the difference between structural and nominal typing. It's like one of the first things that's in most like intro to TS things. I don't know that it's the most important distinction, but like the one sentence answer to the difference is structural typing deals with what like properties and methods an object has. Nominal typing is what it was it called. So if I have a student that has a first name and a last name, and I have a person that has a first name and a last name, TypeScript doesn't make any distinction between those. Nominally typed languages like Java do. They go, yeah, one of them is a person, one of them is a student. Totally different things. As long as it swims like a duck and quacks like a duck and flies like a duck, TypeScript doesn't give a shit. That's one of the ways that it's able to infer most things. Cool. That's kind of like all you really need to know about TypeScript to start using it. Questions about like this big picture stuff?
If you have a TypeScript, do you not need, say, a just test to go on? I mean, what's the difference in the two?
Oh, great question. So tests and types do very similar things, and both of them are quality tools. So if you've read this stuff about trophy testing, we have this base, and it gets a little bit wider at the top, and then it has the little thing on top. So that's a trophy, the trophy test pattern. That's end-to-end tests. That's integration tests. This is unit tests. This is static tests. Types are a static test. So this is actually one of the reasons that we don't need to do quite so many unit tests, because the kinds of things that you do a lot in unit tests are what happens if you pass a number into this thing that's expecting a string? Does it throw an error the right way and whatever else? If our types are taking care of that for us, that's a lot less unit tests that we need to write. Linting, I guess, is another kind of static test. So like TypeScript and Jest in particular are pals. So we can use TypeScript to take care of like a lot of really common cases. And then stuff, but TypeScript won't check your logic for you, just the types. It doesn't catch what we call logic errors, where, no, I gave it 2 numbers, but it subtracted them instead of adding them. TypeScript can't help you with that. Tests can, though. So this allows us to use Jest for like testing the logic of our application, TypeScript to test the structure of our application. You can think of TypeScript as like the building codes for a building. Jest is like, we made an apartment building and not a hospital, right? Sharon, does that answer the question?
Does. What program would be doing the end-to-end or the integration test?
Great question. So we're not going to do any end-to-end testing in this program. The 3 most popular tools for it, though, Cypress is probably the biggest one right now. I've started moving away from it in favor of a tool called Playwright by Microsoft. And the longest running one, and I have a hunch that this is probably what Ford uses, is called Selenium. All of these are browser automation tools. So they go, open up a browser, go to this URL, look in the DOM, make sure this thing is on the page, click this button. Those tools do all of that. Just doesn't really have a great way to do any of that. And then these things kind of blend a little bit. Some of the integration-y things that you might do are maybe more of these tools. Some of the integration-y kinds of things you might do might also use Jest, but slightly differently than we've been learning it. Like, for example, you can take an Angular component and render it with Jest and then make assertions about that component. It's a little bit more complicated than what we've been doing, but that's where those 2 things kind of come together.
I have a question.
Yeah.
I don't know if this is jumping ahead, but when it comes to testing Jest, your TypeScript, do you test your TypeScript or do you test the JavaScript that compiled?
Great question. Do we test the TypeScript or we test the JavaScript? You can do either, and really the logic should be identical in them, because all TypeScript is doing is adding the types, and those either compile or not. That's like a binary sort of thing. Yes or no. So if they do compile, then there's no logic difference between the TypeScript or the JavaScript. Now, that said, I generally recommend testing the TypeScript. And you need to do some kind of specific things with Jest to do that. There's a variant of Jest called TS Jest that will test TypeScript directly. And really what it's doing is it just also does your TypeScript compilation for you. And I have instructions on how to do that in the LMS.
Okay, thank you.
Other questions? One other thing you got to know about TS is it compiles to JavaScript. One distinction you'll see people make a lot is it doesn't actually compile, it transpiles. This is like an academic distinction. Like, it's not super important to be great at differentiating between compilation and transpilation. But the gist is TypeScript and JavaScript are at the same level of abstraction. So if we think of like, we got beeps and boops down here. This is what it ultimately gets to. And above that is machine code. And above that is assembly. And JavaScript's an interpreted language. So like it's probably C++ in between there. So when you go down this one step closer to beeps and boops, each of those steps is called compiling. If you go to, nah, this is at the same level, I'm just adding features to it, that's technically called transpiling. Some things you'll see make a big distinction about that. TypeScript itself does not. TypeScript calls it compiling. So maybe don't worry too much about it. But you write TypeScript, your browser does not know how to run TypeScript. Node does not know how to run TypeScript. Both of them need it to be compiled into JavaScript first. So we're adding an extra step to the process, and in exchange, we get type safety. Questions about compilation, transpilation? All right, let's start writing some TypeScript. Why don't you pull open your terminal. Get yourself over to an empty folder. And get ready to follow along with me. I'll give you a sec. All right, so I'm going to make a new folder. Call this TS lesson. All right, nothing in this folder, nothing up this sleeve, nothing up this sleeve. So we get TypeScript through NPM. So that means that we need to initialize a node project. Even if we're doing a browser app, TypeScript is a node module. So we use node to compile it from TypeScript to JavaScript. And then we npm install TypeScript.
That's all
Echo.
lowercase. TypeScript is put out lowercase.
All lowercase.
Okay.
And that's something we have to do every time we
Every
do
single time.
the TypeScript? Okay.
Yeah, you don't install TypeScript to your computer. You set it up on the project. Then, to set up, to like kind of enable TypeScript on this, we have the compiler installed. we need to tell it where all of our stuff is. We need to configure it. So to do that, it's going to be npx, not npm, npx tsc -- init. So when we npm installed TypeScript, that gave us the compiler. npx tsc is the command to run the compiler. And -- init, here, check it out. This is what's in the folder right now. Just the package JSON, the lock file for it, and the node modules. When I npx tsc -- init, and take a look in here, it also added this tsconfig.json. Anything we need to set up about like our TypeScript environment, all that goes in that file. It's like the configuration file for TypeScript. We're just going to roll with the defaults it gave us for right now, but if you take a look in the file, it actually tells you, so all of these are the options, and then the comments next to them are what each of those options does. Tons and tons and tons and tons of options. And if you you don't need to follow along with this part. If you delete all of them, you can see just what the defaults are. So that's what you get just out of the box by running TypeScript TSC init. It assumes that you're using a fairly modern version of JavaScript. Believe it or not, that counts as fairly modern. Don't worry too much about that or this. Strict is really where the magic happens. Strict makes it really mean about everything it can possibly be mean about. And we want that. That gives us more secure code. Actually, I'll leave it for right there. That's what's in that file. And then to actually compile TypeScript, let's make a file called index.ts. Nothing in it. Then watch what happens if I npx tsc index.ts. List the files. Now I have an index.js also. I compiled that empty file into a JavaScript file. That type checked it for me. So now whatever was in index.ts, because it pooped out a JS file, that JS file is now type safe.
Does it normally take a while to do the npx tsc index.ts?
I suppose that depends on the speed of your computer. And so, yes, it very well might. Questions so far? All right, let's see TypeScript in action. If we open up the index.ts file and a text editor, we can write some JavaScript code. So I might say make a const called SomeString. log it. Cool, easy enough. Like, there's nothing special TypeScript about this. That's just regular old JavaScript. Because regular old JavaScript is also valid TypeScript. And in fact, I can compile that. And if I take a look at what's in index.js now, turn my const into a var, but other than that, exact same code.
And that's always going to replace what was there previously.
Yep. Yeah, it's always going to overwrite whatever was already in the file. And like as such, you never do anything with the JavaScript files directly. The JS files are like the compiler's property.
So you wouldn't go in there and edit those afterwards. You would want to do it in the TypeScript first, and
Exactly.
then okay.
You should never edit the JavaScript file yourself, because it'll just get overwritten as soon as you save a change to your TypeScript stuff.
As far as compiling, do we have to, if we had like multiple TypeScript files, is there a way to do all of them at once, or do we have to compile them at the same time?
Yes. So what you'd actually do, so we're using like npx tsc and then giving it a specific file. That's fine. You can also tell it in the tsconfig JSON where where your TS files are, what their pattern is, like any of that kind of stuff. And then if you just run npx tsc, it's going to look for all of those and then compile or transpile all of them at the same time. So if I pull up the LMS guide to that. I've only been writing TypeScript for a couple of years, so I don't have all the config stuff memorized as good as I do some of the JavaScript stuff. Like, in contrast, I've been writing Node for like 10. All right, this include option says like, hey, where are the where are the source files at? So maybe I say, all right, I'm going to put all of my TypeScript stuff inside of a folder called src. So I make a folder called src. I move my index.ts into src. And then I need a place to put all of my like compiled TypeScript stuff. So maybe that's like, I make a directory called dist for like distribution. src and dist are like conventions. I don't love them, but they sure are old. So, all right, so I've got those two things. My, all right, so my folder kind of looks like this right now. And if I edit the tsconfig to also have a include, that's an object array, an array of strings. Say, hey, by the way, all of my stuff is in this src folder. And then I can also have this outdir that says like where the compiled code goes. So TS files are in include. Outdir is the JS files. Oops. Just be like outdir dist. So if I do that, watch what happens. npx tsc all by itself. And now that dist folder has the index.js file. I can just delete that other one.
Can you go back to your TS config real fast?
Yeah. The only things I changed were adding this array of folders that have TypeScript stuff in them, and this outdir that should contain all of those, all the compiled versions. So now I can do stuff like npx tsc watch. And now it's going to be continuously compiling these. Every time I save a change in a TS file, it'll just recompile them and put them in that folder. Watch. So this one's the compiler. This one's the editor. npx tsc watch over here. Shell there. If I go into the TypeScript file and call this goodbye home. So watch what happens when I save this. And then if I go over to the shell, there it is. If I
Perfect,
go, nope,
thank you.
psych, I want it back the other way. Now it's that.
Quick question.
Yeah.
Rather than going through the TS config to add multiples, could you just, from the command line, just do npx tsc and then say like file1.ts, file2.ts?
Yep. That works too.
Okay. Okay.
Other questions thus far?
No, I couldn't follow along because my index.ts information didn't go over to my index.js, but
Oh no, well let's fix that. Let's figure out what happened. You're probably not the only one. All right, so I see you got an index.ts file there. I see you have a TS config. And sure looks like it compiled. So try opening up your, okay, so I see you've got your index.ts there. Try compiling it.
doing the npx.ts.
npx tsc index.ts.
Yeah, it took it a long time.
Yeah. These are really slow computers. You guys are gonna have your, and there's no way, even like at like a company like yours, that like they have the software developers using computers this slow.
Why?
That's like lighting time on fire.
It could just, I don't know. Mine was almost instantaneous when I did it.
Oh, interesting.
Yeah,
Same
mine
for
didn't.
me, yeah.
Mine was like you could maybe 3 beats. You were like 1, 2, 3, done.
Huh?
Mine was even
Yeah,
faster than
I
that.
think we all have computers of different speeds. I've noticed that when I'm working with you guys. Some of y'all have pretty slow computers.
All right. So Sharon, now try your cat index.js.
Okay.
You're in business.
Okay. Thanks.
Very welcome. So, other questions so far about getting TypeScript set up, compiling, any of that sort of stuff?
So when I cat the index.js, it doesn't do anything. If I cat the TS, it does something.
All right. And your compilation ran?
I'm not sure. I did the TS config and I saved it. What was the compile again?
npx tsc and then the name of the file.
Okay, cool. I missed that part the second time around.
Excellent. So yeah, that npx tsc is like, yo, can you type check this? And assuming everything checks out, you can turn it into a JavaScript file. And then if you set up like your include and your outdir, then you can have it do that automatically with anything that ends in ts in like your include folders, and so on.
I have a question.
Mhm.
So when I cat the index.js file after it's compiled, it uses var. But
Yeah.
when I open it in VS Code, it switches to const.
Yeah.
What's doing that?
ESLint probably.
Okay.
Because ESLint's going, hey, buddy, it's present day. And so it tries to fix it for you. That's one of the reasons, that's yet another reason to like really never do anything with the JavaScript files.
So by putting things into source, when we're going to test, should we have our testing files in something else as well, like a test folder, or?
Yes. That's usually a smart move. Or like, I don't know, there's a bunch of different ways you can do it. A lot of people, including increasingly me, like keeping the test file right next to the file that it's testing.
Okay.
Or you can keep all the tests in the same place, which is what I did, I don't know, most of the last few years. Just a
So
style
put
thing.
the test in with your source and basically install all of your tests in there, or?
Yeah, so like, check this out.
Not to get off topic, but
For the LMS, no, it actually reminds me I need to write a thing on file organization for you guys. If I go over to the LMS, I mostly did in the same folder. So like, there's that file, and then there's the test for that file. And actually, yeah, I have all of these. So this is the TS file. That's the JS file that it compiles to. This map file is, don't worry about it, but like all of those are related. And then this, the JavaScript file that was that this was testing, that was the TypeScript file that it came from. That's a mapping of how I went from one to the other. So I tend to like to keep these in the same directory anymore, but there's plenty of stuff in here. where, yeah, this one, I keep all the tests in the same place on this one. Or this one, yeah, all the tests are in the same place. That's a fine way to do it. Or there's a strategy called pods that I do on the front end for this. So each one of these components is like a single piece of the LMS, like the header. And every one of those has a style sheet and like a TS file and a test, and then something that kind of links them all together. That's a third strategy for that. Lots of different ways to do it. Other questions so far? All right, so let's start talking about some type annotations. So to annotate a type, you take whatever the name of the thing is, put a colon after it, and then tell it what type it is. So that exact same code, didn't change anything. Actually, if you've been reading, it was a type literal, and I've actually widened it to be any string. It's one of the reasons that like you probably should annotate as little as possible. It's like that's not all that useful. It will catch like stupid errors like that. Number is not assignable to type string. Cool, just an extra error, just helping us out. Where you're going to end up doing most of your type annotations is with functions. So if this function, or if this is a function called like print greeting, and this was actually something more like console log hello name, and we take name in, that needs to get annotated. And it's telling me right now, parameter name implicitly has any type. Any means untyped. And with the defaults in our TS config, we're not allowed to use any. So we need to tell it what type that will be. Like that. This is where this gets cool. Now that we've done that, down here when I'm calling print greeting, if I do that, no problem. In fact, even still compiles just fine. If I try to do that, argument of type number is not assignable to parameter of type string. It caught an error for me. That's a type error. If I accidentally forget that it's looking for that string and I try to pass in an object with a name instead, argument of type name that's a string is not assignable to parameter of type string. Caught an error for me. That's pretty helpful. Because if I didn't have TypeScript and I tried to run this, I'm going to get hello object object. That caught that for me right away. That's pretty cool.
What if we try to pass in nothing? Like a null.
Great question. So if I try to do that, expected one argument but got 0. JavaScript doesn't care. JavaScript won't tell you
right.
that.
Gotcha.
If I try to pass in null, Argument of type null, because remember, null is a type. It's a primitive type in JavaScript, not assignable to string.
So you'd have to put that in quotes, and then it would take it as if it was a name.
Well, yeah, and that's not a special type. That's just a
Right, that's
string
not type
has
anymore.
those full
That becomes
characters
a
in it.
string. Gotcha.
That's type safety. Catches your mistakes before you even see them.
I have a question.
Mhm.
Sorry. So like my way of like writing this out is like, because you said you have to type as and until as least as possible.
Yes.
So like when I've been working on stuff so far, I've like been typing it like normal unless it says, hey, you have to annotate this, then I do it. Is that a good way, or should I require more forethought?
Nope. That is like, that's actually it's one of these things where like a lot of people when they're new to TypeScript just start slapping types on everything. That's a better way to do it. And it's a little counterintuitive because it's so much less work. But basically, if you only annotate a type when it tells you you have to, that's a pretty good way to do it.
Okay, yeah, because I feel like I'm missing something. Like, I feel like I'm missing something.
No, it really
Okay.
is that easy. And so what he's talking about is if I leave the type annotation off of this, like that's just the regular JavaScript, it'll get mad at you. Hey, that implicitly has an any type. All right. Make the error go away. That is as much typing as you need to do. If all you do is just add types when it tells you that you've implicitly used any, you are like 80% of the way to grokking TypeScript. Other questions?
You have to run the npx TSC every time you make a change because mine's not updating.
That sure would be annoying, wouldn't it? So the way around that is if you add these to your TS config, that's like a folder, or it could just be a file, some kind of path of where to look for TypeScript files. And that's where to put them when it's done. And that's optional too. If you do that, it'll just do them in place.
That's the part I missed when I was trying to wait on that the first time. So, okay, I got you. I'll change it.
And then the other part of that is over here. So adding that like include and outdir, that'll make it so you don't need to specify what the file is. And so you can just run npx tsc. No problem, compiles it for you. If you add the watch to it, that will continuously do it. Every time you change a TypeScript file, it'll recompile everything. More questions? Cool. So if this seems like super easy, it's because it is. Like, let's take a look at a solution to like the resistor exercises in TypeScript. Oops. Okay, so this is resistor color trio TypeScript. And if I go over to the solution, oh, this one has a few. But like, let's take a look at what some of the types are. So that's a function. If I take out the type parts of it, it looks like that. So that's just regular JavaScript. What this says is that this parameter is a string. This thing after it says that it returns a string. I generally don't expect you to or recommend that you annotate your return types. There's a not dumb reason to do that, but if you leave that off, it doesn't get mad at you or anything. We'll talk about that in the next unit. But basically, this is declaring a type. And this is saying that units is an array of those types. All right, this one is, it's a little hard to see because of like where the lines are broken up, but it's a function. So these are the parameters between there and there. And it's saying it's an array that has that and that and that as arguments. And that all of them are strings. And then it returns a string. Forcing that to be a string. And that's it. If I look at one of the easier ones. Resistor color TS. The only like TypeScript in here is that function, parameter annotation, and the return type. Color code takes in a color, which is a string, returns a number. Ta-da!
For your type aliases, do you put them like right above, like right where you're going to call them, or at the top of the file? Does not really matter.
That's a great question. I'd put them pretty close to where you're using them.
Okay.
There's a good argument for not doing that, though. In fact, there's a pretty strong argument for putting them in another file entirely and importing them. Like you can export types the same way you can export values. But yeah, for now, I'd keep them pretty close to where you're using them. The most difficult thing about getting started with this is the syntax. Not accidentally turning this into an object by wrapping it in curly braces. Remembering which things are colons and which things are equals. And that stuff is just practice. The more you do it, the faster you'll get at it. Just like regular JavaScript stuff. Where this starts getting tricky is when we're working with objects and functions. So like that's easy enough. If I had a function that was like print person details and it takes in a person and logs person dot first name and person dot last name and person dot age. All right, so it's mad at me. Parameter person implicitly has any type. All right, well, it's a string. All right, well, now these are mad at me because strings don't have first name properties. Strings don't have last name properties. Strings don't have ages. All right, cool. So person's an object. So I do const person equals first name Kyle, last name Coverly, age 2. Okay, I pass that in. Uh-oh, still mad at me. Argument of that type is not assignable to parameter of type string. Yeah, it's not a string. Okay, fine, it's an object. Oops, still mad at me. What the hell, TypeScript? Property first name does not exist on type object. Yeah, it's not on every object. This is where this gets trickier. So you can make a type called person. And you can say a person is an object that has a first name that's a string, has a last name that's a string, and an age that's a number. And then I can say this takes in a person that is of type person. And now everything works.
And that's in the global scope? The type is or no?
It uses the same scoping rules as variables do, like block
Okay.
scoping variables. Actually, I think it's a declaration technically. So when you're using objects, you need to declare what the shape of the object is. Like that. But then you can use that just like every other type. And that's how it knows that it can safely do first name, last name, age. That type guarantees that those will be there. I can even further guarantee that by putting that on there. I don't need to though. It'll infer it.
Hey, Kyle.
Yeah.
This was actually one of our one of our questions that we in one of our as we go through your assignments for this. It actually says how do you take a function that has an object that has these certain attributes.
Yeah.
But when I went through the lessons, this wasn't defined clearly. In fact, last night I was Googling a lot trying to find this answer exactly how you just showed it.
Yeah.
Can you add this to that part of the lesson for future? Just because this is actually kind of the answer to that question, but I couldn't find it last night. So when you get through my questions, you'll see I did something similar, but I didn't do that middle part where I created the type person, first name string, last name string, age number. I didn't know how to do that. And I couldn't find how to do it.
So keep in mind too that the stuff that like I can add that in there.
Okay.
The stuff that I write is not comprehensive and like will never be. In fact, it's going to get a lot thinner as the program goes on. Where you can get a lot of that stuff is if like you look at this thing here, you should really go through like all of these. These additional resources, I went to school too. A lot of these are like, that's a book or like extremely optional thing. Like a lot of these resources, I highly recommend you go through. In fact, when I was putting together this curriculum, I was trying to find like a great TypeScript book that I could just rip off. And I really couldn't find a good beginner's one, which is weird. Like TypeScript has been around long enough and there's a cottage industry for this shit. I was like, where's the like awesome beginner's TypeScript book? And I can just use all their exercises and like their structure and stuff. And like the reality is the official TypeScript docs on this are the best docs I have ever read for any technology. They are so fucking good. And so if you go through the official stuff, it'll be better than anything I could possibly write. Like I'm really impressed with how good these are.
Gotcha. I did scan it. I'll probably have to dig in deeper then. I couldn't find how in TypeScript to create an object with attributes like that.
There you go.
Oh, see, I didn't scan it good enough.
And you'll see like a lot of these things will use interface instead of type. They do the exact same thing. We're going to use the type stuff and everything in this unit. And the next unit, we'll start talking about interfaces. They're interchangeable. They do the exact same thing. Under the hood, they're identical. Philosophically, they represent two different ideas. Other questions about object types? To get in front of this, because it will fuck you up, I promise. Everybody's going to screw this up like 30 times this week. Those end in semicolons, not commas. It's not an object. It kind of looks like an object because it also has curly braces and it's describing the shape of an object. It is its own syntax. Like that. One other thing I'll throw at you, arrays. So let's say I had a property on here that was like intact limbs. And it was an array with like front leg, left leg, right leg, that kind of thing. So the actual value of it would be like intact limbs. Front arm, come on. Right arm, left arm, right leg, left leg. Okay, so the correct way to type that is like it's an array of strings. You put the array brackets next to the type. Everything that I've raised you with so far has you using the exact same type for every item in an array. Stick with that. There is a name for one that uses mixed types. It's called a tuple. Don't use tuples. They have a place, but you can live a happy, healthy life without using tuples. Use an object instead. So yeah, when you're using arrays, it's an array of Pokemon. It's an array of people. It's an array of race car drivers. It's an array of like spaceship things or whatever. Those should all have the same shape to them. So that's the way you do that. You can do like a type class. No, I can't use class. Course is, it has a title. Not my title, by the way. I really do not like the word academy, but that's a petty thing to get mad about. And I have like people is an array of persons. You can do that too. Oops, except, see, look, I did it. Those need to be semicolons.
So for that course, did you hard code that string? I guess I'm just.
Oh, come on.
It's different than the type
Really?
above.
Good gravy. Const course is of type course. Although that works. Like, I could have done it that way. Can anybody tell me what that would have been if I'd left the title in there as that string? It was a vocab word.
I'm just guessing, but type literal.
Yes! That is a type literal. I can say that this is the only legal value of that field. That's valid code. Where you tend to see that is I can say that it's either that or you can make like so that says it's either that or that, but it's not any possible string. It's one of those two things. And I actually do that with the labels. They're called slugs for each of the lessons in the LMS. A slug can't be any string. A slug is specifically oops, that's not going to work. Nope, stop, shut up. Man, that list is getting long. It has to be one of these specific strings. And that actually ends up catching a ton of errors when I'm writing the config files for the LMS. Because if I accidentally do API integration vocab 3, well, there isn't one. And so it'll tell me that because it's this union of type literals. If I just say string, it doesn't catch the error. Could also do that with like is active. If it's a Boolean, just do that. If you have to like pull that out of the strings, it might be like active or inactive. That's like another use of that. Or maybe that's like status then. So a good place to get started with practicing this stuff. Head over to the practice exercises. I have TypeScript versions of every single one of them. Do one that like you're already comfortable with. We've done a bunch of them in the warm-ups and stuff, and like a couple of them are pretty easy, like the twofer. All have TypeScript versions. That's a great place to get your sea legs. Any other questions about getting started with TypeScript?
I have two questions.
Yeah.
And I'm done. All right. So the first one is like, so when you're doing TypeScript and you're selecting a HTML element,
Yes.
it gives you a warning saying a possible null. And like when I read online, it said you can either put in the if statement or just put an exclamation mark if you know for sure it's going to be in your HTML file. Is the second option good?
The exclamation points are escape hatches. I'm going to say you're not allowed to use them. So here's how you get around that. Like, query strings will always return back like the element that you're looking for or null. So if I'm doing something like some element is document.query selector, and then I need to tell it what kind of element it is. This is a thing called a generic. There's a section on this in the reading. So like HTML li element. Give me an li. So that's really some li. if I want to do something on that, like for example, set its text content, that's actually not a safe operation because it could come back as null. Null doesn't have a .text content property. That'll just break your code. So the way around that, just check for it first. No error. Because TypeScript is smart enough that it can follow the logic of your code a little bit. It knows that it's not possible for some li to be null and still get into this block. That means it was either going to be null or an HTML li element. We've just narrowed it down so that we know that it's not null. Ergo, it has a text content property.
Okay, thank you. Yeah, that was the other option. Yeah.
Yeah, do that one.
Okay.
Because it's really easy to get in the habit of just exclamation pointing everything, and then you're not getting type safety anymore. Because you think there's an li on the page until you write some other piece of code that rips it out.
Oh, okay, yeah. That makes sense. Because I was like, well, if I put in my HTML file, it's always going to be there. But no, okay, that makes sense.
Yeah, or like you refactor your HTML and you go, oh, I'm using paragraph tags instead of LIs. Well, now your like TypeScript code can't tell you, yo, you also need to change this.
Okay. And my last question is, so like, if you're working on a project, you have two separate TypeScript files, and you go to reuse, like you want to grab URLs on both.
Yes.
It doesn't let you use the same variable name on two separate files. It told me that I was trying to redefine block scope variable.
That shouldn't be the case. So if I make a second file, this was TS. So if I do an app.ts file in that source directory also, so now this has both of those. And I open up app.ts over here. Oh, how strange. Oh, I know why it is. Interesting.
Yeah, I know why too. This is what I researched. So it's like if, for example, it doesn't know that like if you put them both in the same like HTML file, right, one after the other, it can overwrite the second file without you meaning to.
Right, but check this out. This is like the fundamental problem. Take a look at what's happening in our dist folder. Oh yeah, like it's essentially what you were just saying. If I'm doing this in a browser with like source files and stuff, I might do include one in the source and then include in the next one in the source, and yeah, they're still effectively in the global scope. Yikes! So I'll bet this gets around it. Watch what happens to the error. Yep.
That's what they said, use modules.
Yeah, as soon as it's a module, now the type checker has confidence that these things are isolated. And so that can't happen. If you're not treating it as a module, it's assuming you're going to throw it in a browser, and we could run into that problem. And like a good way to cognitively reframe the frustration that you are going to feel when TypeScript is telling you those things is that like, yeah, it's kind of an asshole, except it's always right. Like, that is always actually a problem. That is always actually a risk. It's looking out for you. It's kind of like your lawyer. And so TypeScript is generally right, and you are generally wrong. And so if TypeScript is barking at you for something like that, take its advice. So I'm going to keep using that metaphor. I like that. TypeScript is your JavaScript lawyer. Hey, I just want to set the text content of that. Yes, but under subsection 36b, said element may not actually exist, so it would be most prudent if you... You still want to punch him in the face, but he's keeping you from getting sued. Other questions about TypeScript? All right, go and be well. Have fun with it.